Hi, and welcome back to C Beginner to Pro series. In this video, I'll be dealing with conditionals and loops, also covering some very basic things related to Boolean algebra, which I believe are necessary for conditionals. Now, this was the program we were dealing with in the last episode. As you can see, it was our main program that just said first program and hello world. And if you remember, it executed sequentially, so line by line. Here you can see a flow of the graph. Starting with void main, then we go to the first program print and then to the hello world print. However, this is a very boring type of execution, and sometimes you might want to do conditional execution. So as you can see, we start from void main and sometimes we print A and sometimes we print B. In order to achieve this in C and in most modern languages, we use if statements or conditional statements, conditional branches or whatever you want to call them. An example of such you can see here. So we have our main program, we assign A to be equal to 3 or whatever, doesn't matter. And then this is the new part that we have not seen until now. We see if bracket A is less than 4 bracket and then scope print A, else print B. So let's dive into this and understand what this new portion of the code is, what it does, and how to write codes like that. First off, here between these two circular brackets, we see this A less than 4. This is called a conditional. Conditionals are either true or false. If you remember in the first video or last video, there was a section about bits where I said that 1 means that the bit is on, or it can mean that it's true, or 0, the bit is off or false. In C, it is something very similar. Unlike some other languages like Python and Java and most modern languages, C does not have a notion of booleans. So what it has is integers, so int, and in int 0 means false, and everything that is not 0 is true. So this is a very broad definition. This means that -1 is true, 1 is true, 100,000 is true. As long as it's not 0, it is equivalent to true. So in C, true and false are derived from 0, which is false, and everything that is not false is true. It doesn't lead to too many problems, but it's just, I think, for some people that have just started working from other languages, it can be a bit hard to understand. So yeah, C doesn't have booleans. It uses integers to replace booleans. So whenever you do a conditional, like in the last slide, so A is less than 4, this is evaluated to an integer that is either 0 or not 0, and from then on, this has some internal meaning to C to be either 0 or false. So, examples of conditionals, you have the arithmetic operators, less than, greater than, equals is 2 equal signs. This is because 1 equal sign means assignment. So 6 equal to 3. Not 6 equal to 3. A equal to 3 means A is assigned to be 3. However, A equals 3 is a conditional check. We're checking if A is equal to 3. We also have different, which is exclamation mark equal sign. And we also have the less than or equal and the greater than or equal signs over here. So less than, greater than. These are just the same as in normal mathematics. Now, just to give an example of what happens if you mistakenly put A equals to 3 in your conditional part. So if you remember over here, here's the code we had. This one here is our conditional statement. What if we want to check if A is equal to 3? We should put 2 equal signs. And down here we should see A printed because we are in this part of the code, and as you can see, this part of the code is not executed. However, if we make A equal to 5, let's say, anything that's not 3, we'll see B printed, right? The else part is printed. Now, what happens if we say A is equal to 3 over here, so mistakenly we add only 1 equal sign? Well, we will get A. This seems similar to what we had before. However, now let's set A equal to 6, and we still get A. So if you mistakenly only put 1 equal sign instead of 2, what happens is this assignment is performed. So A is set to 3. We can verify this by printing here at the end. If you remember, we printed like this. And we'll see that A is, I forgot the semicolon at the end, even though in the first video I explained we should always put them at the end. You can see A has been set to 3. So the assignment was performed successfully, so this returns some integer that is not 0. We can even check what that is. This should work in theory, so we set it equal to A. I think it's going to complain, however. Let's see. Oh, it does not complain. So we can see what the result of this assignment is. It is 3. Okay, so this assignment has returned. So we see B equals A equals 3. B is set to be equal to the, we can even make it like this. B is set to be equal to the result of the assignment here, which in this case is 3, which is not 0, so it's true. So the assignment was successful. However, here what we want to check is A equal to 3, and for that we need 2 equal signs. So be aware of that. In other languages, the compiler or interpreter will complain about this. In C, as I said, it's very loose, so it will not complain, and it's a source of mistakes. So people oftentimes recommend you first put your constants, so like 3 and that, and then do equal A. That way, if you mistakenly only put one sign, so you try to assign A to 3, you see an error. So the compiler will complain. This is a matter of personal preference. I personally don't do that. I always write A equals 3 because that's how I'm used to it, and I try to avoid mistakes. And if I make a mistake, I try to see it. There's many tools which can help you with that. If you use the GCC compiler on your computer and you run it with warnings, it's going to raise a warning and say, hey, you probably don't mean to use one equal sign here. But this is for later on. Anyways, we now understand what conditionals are, right? And now we can take a greater look into what we have here with the if statement, right? I separated the brackets, the curly brackets, onto a new line so we can see the blocks. So we have our conditional in here, right? We have if, then circular bracket, or just a normal bracket, or they're called parentheses. Actually, I think they're called parentheses. I've been calling them brackets mistakenly. So parentheses, and between the parentheses, we have our conditional statement. And then what we have is these two things. So these two blocks between these brackets is what is executed when the conditional evaluates to true. So evaluates to something that is not 0. And here we have when is false. So it's evaluated to something that is 0. As we saw before, if we have, actually let's pull it out again over here. So let's fix this and set, we're checking A to be equal to 3. We see printing A. So this part of the block is executed. Here we assign A to 3. We can now get rid of this line because we don't need it anymore for this example. So now we'll see the second line because A is now 6. 6 is different from 3, so we're getting into the part of the code that is about the false assignment, right? Which is over here. And now if we set A to be equal to 3, or we put here actually A different from 3, we should now see A being printed because we're in the part of the block which that is executed when this conditional evaluates to true. So you can see the syntax of if. We can generalize it like this. So if, and in the parentheses, your condition. And then in the first part, what do we do when the condition is true? And then else, what do we do when the condition is false? And then the program will continue normally after this branching execution. You don't need the else statement technically, you can work without it. So here we have without the else statement, so we have if condition, and then we do whatever if the condition is true, and then we continue the program normally. If the condition evaluated to false, we don't do here, and we just continue the program normally. Here's an example. As we did in the tutorial, let's go over the code line by line and see what happens. In the first line, we assign A equal to be 3. We go into the if statement. We evaluate the condition. In this case, it is true. 3 is indeed less than 4. We assign A to be equal to 9. We print A, and the next line is over here because we skipped the false part of the statement, and we go print whatever the value of A is currently. So what we will see on the terminal, if we write out this program right now, we should see A and then 9 being printed. Let's open up the code again. We have A assigned to 3. We check if A is less than 4. We assign A equal to be to 9 here, and here A to be equal to 6. And then we print here the value that we currently have of A. Like this, and then almost forgot the semicolon again. So as you can see, yeah, I forgot a semicolon here as well. We see A9 as we expected to see. However, now let's try to make the condition false. That is, let's set it, for example, to be equal to 4. We set A equal to be 4. We evaluate the condition. Now 4 is not less than 4. 4 is equal to 4. So we should get into the false section in the else part. So on the first line, we assign A to be equal to 6. We print B. And finally, we print the value of A. So the program continues normally after we leave this else block. So if we open up the code again, we should see B6 printed if we set A equal to B4. And that is indeed what we see here. Now you can, these were pretty basic if-else statements. You can make them a bit more complex by making use of else-if. So the way you use else-if is you have your first if and then your first condition. And then in this part of the block here, we write whatever we want to happen when this condition here evaluates to true. Then, the block ends with this bracket. We do else space if, and then we write a second condition. And then in this section here, between these two brackets, we write what do we do when this one has evaluated to false and this one has evaluated to true. So what would happen is, in this case, if this is true, it will execute here. And since this was true, we just continue program normally. If this were false, it will check if this condition is true. If it's true, we do this. And once we reach the end of here, we continue program normally. If this was false, then this was false. Then we'll go here, evaluate to see if this is true. If it's true, we do here and continue program as normally. So as you can see, you can chain as many if statements you want like this. And they'll be executed in this almost cascading fashion, right? First one evaluates to false. Is the second one true? Okay, it's not true. The third one, and you can chain as many as you want like this. So here's an example again with an else if statement. We set A equal to be 7. We check the first condition. It's not true. 7 is greater than 4. So we go and evaluate the second condition technically. 7 is less than 10. So we have A set now to 6. We print B and we print the value of A. We could have here, if we had put, let's say, 15, something that's greater than 10 or equal to 10, what would happen is we'll check this condition, it will evaluate to false. We'll go here, check this condition, it will also evaluate to false. And we'll go here, we'll set A equal to be 31, we'll print C, and we'll continue the program as normally. So I hope this clears how the syntax works for you. I will end this video here for the sake of simplicity to keep the videos shorter in length. And in the next video, I will explore Boolean algebra, which I think is very essential when you want to understand if-else statements and want to create more complex conditional structure. So I hope to see you in that next video, and if you found this tutorial useful or helpful, please consider leaving a like and subscribing. It greatly helps out my channel. Thank you for watching.